All right, today we're going to talk about increasing and decreasing functions. It's going to be a great time here at Endpoint Math. Hopefully this is helpful for you today when you're going to investigate what on earth an increasing function is versus an increasing interval and all these sorts of things. So let's dig right into it. Increasing function is increasing on an interval a to b. So we're just going to pick some random interval from a to b that we're going to be analyzing. So these intervals are always x values when we do this sort of thing. A function is increasing if on that interval we pick some sort of c and d where c is less than d. Okay, so this might be c, this might be d. Wherever the heck we put it, as long as c has to be to the left of D on the graph. And the output of C has to be smaller than the output of D. So if this were this point, that would be C, comma, f of C, right? We're talking about a function here, some function f. Then D would be up higher. The output is higher at D. Again, wherever the heck you put these things. All right, if this is the case, that as we go left to right on this thing, C is under D, just like A was under B, and if the output of the first one is smaller than the output of the second one, this is the definition of increasing. And you can imagine if this were your bank account, it's increasing, right? That's all it is it's going up and to the right in some way. Not going flat, or not going downhill, it is going up and to the right. But this is one way you can define it with just generic points, c comma f of c, and then I guess I should fill in this other one. This is d comma f of d. All right, does that sort of make sense here? That means that we are always increasing from a to b. We're just talking about from a to b. All right, a decreasing function is very similar. So let's go over here. We're going to have an interval from, I guess I should do it in red to be consistent, right? A to B, some a to b, wherever the heck those are. And then once again, we're going to have a c value that is smaller than a d value. I just happen to put them at -2 and 2. They could be anywhere. Now this time, the output of C is bigger than the output of D. Aha. So the first dot is going to be higher than the second dot. No matter where we put these, the first dot would have to be higher than the second one. That means on this interval, A to B, if this is always true, that the output at C is bigger than the output at D, then this is a decreasing. So this is decreasing, going downhill, and this would be increasing. So decreasing might be your attention during math class, right? As it just keeps going down further and further, but not during Mr. White's videos, certainly. All right, what about a constant function? A constant function says on an interval A to B again, A to B, you probably know where this is going, right? If I go from C to D, if this is equal to this at all values C and D, then this thing is constant. It's just flat line. So that's what a constant function is. All right, so we can imagine looking at little portions of the graph, which is what we're going to do next. It says using the graph below, find the coordinates of any maxes and mins. Now, I've already done that for you. Wasn't I nice? And state the intervals where the function is decreasing and where it is increasing, and we're going to use interval notation. So let's start with increasing. And then we'll do when it's decreasing. All right, we always think about this left to right. Because remember, A was less than B, was what I said up there. First of all, we're looking on an interval, and we're going to go left to right. So when is this roller coaster going up? That's one way to think about this. So you're riding a roller coaster. Here's your little car. All right, and it is heading this way. It's going this way. So when is it going up? It would be going up. Let me highlight it in maybe red here. This is when it's going up. And then it has a downhill segment, doesn't it? And then it starts going up again. And we're going to actually assume that this goes forever like this, and that this has been coming from forever also. All right, so those two highlighted regions are when it was increasing. So let's write those down. Where did it start? At x equals what? Where did this happen? At x equals negative 2.2. So we're going to do parenthesis negative 2.2. We don't even look at the negative 9.5. I don't even care about that. Right? So we're not asking about y values here. When I ask when is something happening, it's always time, which is generally the x-axis. So the x-axis is what we're talking about here. So negative 2.2 all the way up to 0.04. I almost messed that up. You see how this is 0.04 actually. And then union, when does it start going? We go up again because we got to skip this. This region right here, it was actually going down. So we're going to skip that. And then it starts going up again after 2.9 seconds is one way to think about it. And then forever and ever it goes up. So that's the interval where it's increasing. All right, decreasing would have been from here to here and from here to here. So let's write those. And we always write interval notation thinking left to right. So this would be negative infinity, right over here, negative infinity all the way up to negative 2.2 is where it's going down. And then it goes up for a while. So we're going to skip those numbers. And then it starts going down again at 0.04 all the way, not to infinity, but just until 2.9 seconds, because remember that's when you start going up again. There you go, increasing and decreasing. It's not hard. It really is not hard. So you might want to pause the video and just real quickly see if you can answer this question. This is a little bit hard to see. And I don't give you the function here. You're just sort of looking at the graph. Okay, so we see something happens here. This is like at negative 1.8. Okay, I don't even care about how high it went. We're not reporting any y values on this. When we say when is it increasing and decreasing, don't worry about the y values. I'm going to go all the way down here. This is at about 1.6 or so. And then this is going forever this way, and it's coming forever from this way. So it is increasing from, where is it increasing? From here to here and here to here. Again, we're only reading x values off of that x-axis, so it would be negative infinity, negative infinity all the way to negative 1.8, union 1.6 all the way to infinity and beyond. And then when is it decreasing? It would be decreasing from 1.8 to 1.6, negative 1.8 to 1.6, and that's it. There's no union needed here. There was only one short segment where it was going downhill. I can't say it enough. Read it left to right. Read it left to right, and you can just think about a roller coaster ride. All right, a lot of students focus too much on the y values. We don't report the y values. We're simply reporting the domain where something is happening. When is it going up on these x values? When is it going down on these x values? All right, we're just cruising on, right? All right, so again, pause the video and see if you can report when is it increasing, when is it decreasing. And I'll begin working on it here. Looks like it's increasing like this. That's when it's going up. So increasing would be from negative 2 all the way to 0. This is x equals 0. I notice a lot of students put 9 there. It's so tempting to put 9 there. But it's at 0, 9 is where it happens. Union to infinity. Now, when is it decreasing? We'll do that one, highlight that in blue. From here to here, that's decreasing, decreasing. So when did that happen? That is negative infinity all the way up to x equals negative 2. Union, and then from 0, remember this is x equals 0 right here, x equals 0, all the way to x equals 2. It is decreasing. All right, very good. That's pretty easy, right? Let's add one little layer of difficulty is, let me give you the algebra now. Instead of just giving you a picture, what if I just dropped this in your lap and I said, give me the intervals of increasing or decreasing. Now you should know, since this is an x squared with a positive leading coefficient, you know this thing is some sort of parabola. So it's going to have some sort of min, okay? So you know there's going to be a region of decreasing from negative infinity all the way to something. We're going to figure that out. And then, whatever this number is, that's where we're going to start increasing, and we're going to go all the way to infinity. So we kind of know what to expect. We just had to figure out where this happens. So how could we do that? How could we do that? Well, look what I have ready to go here. You could go to your graphing calculator or Desmos and figure it out. So I wanted to remind you how to do this in a TI graphing calculator, because we're going to find the minimum. So I have the graph ready to go here. Let me hit the graph button. There it is. And we see it is a parabola, much like I drew there. So we're going to need to figure out where that happens. So the way you do that is you do second calculate, so that's trace, second trace, and we're going to find a minimum because this thing bottoms out. And then it says, okay, cool, I can help you with that. Let's go a little to the left. Let's go a little to the right of wherever that little dip is, and then hit the enter again, and it will tell you exactly where it happens. The minimum is at positive 0.750 if you were to round to 3 digits after the decimal point. So this would be 0.750 also. Notice, I care less about the y value in this question. We're only asking or answering when does it happen. All right, I do have another question lined up here, so let's go down to the next one, and this is the last one today, and we're going to be done. So I didn't do the graph, but you could fill in the graph based on the picture that I had there, right? It was at 0.75, it was somewhere around here, and it looked like this. Okay, and we used the TI to find a min. All right, cool, now it's documented. All right, now let's do an x to the third. What do x to the thirds look like? Sometimes they look like this. They can even be like this, where they're just always going up. But I designed this one so it has a max, a local max, and a local min in it. So we need to figure out where those happen, and the TI will be our friend, right? So we will see increasing. We should have a region from negative infinity all the way up to something here. And then we're going to skip some, and we're going to union. So I guess I should watch how I'm writing this off to the right. Okay, and then we're going to union that with another interval, and then it's going to go to infinity after that. There, I squeezed it and I saved it. All right, so let's go to the calculator again, friends. And here we go. I have conveniently already put it in the calculator to save your time, because I don't want to waste your time. So I'm going to turn this graph off and turn this one on. That's kind of neat how you can do that, right? I'm going to hit graph, and there she is. It is a x to the third graph. It looks like it hits about right there or so, and then I'm just kind of guesstimating. It doesn't. We're not looking for zeros in this problem, so actually it's right there. So up, down, and up again. All right, so we're going to figure out these two spots. How are we going to do that? Second trace, which is where calculate is. Second trace gives you calculate. Let's start with the max, the one that's on the left. Enter, and you have to go a little to the left of it. Enter. Go a little to the right. Enter. And just hit enter again, and it'll tell you exactly when that happens. That happens at negative 1, negative 1.535, negative 1.535. All right, and then, by the way, decreasing then, we might as well just get to it. When does it decrease? Well, it starts at negative 1.535, and then that finishes somewhere. So we're going to do the min now. So let's go back to the handy-dandy calculator. We're going to do second trace. Let's calculate. We're going to calculate some cool stuff here. We're going to do a minimum. And this time we're going to go to the right and hit enter. You got to go to the right to give it the interval to look. Hit enter, and it should jump. Oh, it did not. I'm not happy with that. I must have done something wrong. So second trace, we're going to do a minimum. A little to the left, enter. A little to the right, enter. There we go. And then enter again, and it jumped down. Where does it have its min? 0.869. 0.869, and that would be our answer. All right. So sometimes we use the graph is given to us, and sometimes we have to look up the graph. But either way, it wasn't horrible, right? So hopefully you found this video useful, and now you're going to just knock it out of the park with the assignment on increasing and decreasing functions. All right. Hopefully this was helpful, and until next time.